So let's first talk about precondition strengthening. So what's precondition strengthening say? It says that if you already have the Hall triple PWSQ, and PW is a weaker predicate than PS, a stronger predicate, i.e. PS implies PW, you can replace the weaker thing with a stronger thing. And the reason that is because this precondition strengthening makes your Hall triple less useful in a sense, because you want the input to be as general as possible. This thing makes the input more specific. It makes it work for less cases. So if you hear this Hall triple here, what does it say? It says, if x is greater than or equal to 0 before I run the code, I add 1 to x, then it should still be the case afterwards, that x is greater than or equal to 0. Well, if x is equal to 2, that implies x is equal to 0. So this statement's a stronger statement than this weaker statement here. So I could strengthen my precondition by replacing x greater than or equal to 0 to x equal to 2. So what is this statement here saying? It's a promise that if x is equal to 2, and then you run some code that adds 1 to x, I guarantee x is greater than or equal to 0. If, say, x was equal to 1 before you run the code, I make no guarantees. So this is like a strictly less useful statement than what it was. Postcondition weakening is a similar thing, because generally speaking, you'd like to know the most about you'd like to be the most constrained about the output, you'd like to know the most you can about the output, and you'd like to put the least number of constraints on the input. You want the code to work for the most general possible input. So postcondition weakening is also making things worse. And the way it does that, if you've got a predicate P as your precondition, and some code S, and then a postcondition Q sub S, if Q sub S is a stronger statement than Q sub W, then you can replace the stronger postcondition with a weaker postcondition. So you're weakening the postcondition. That's why it's called postcondition weakening. So we'll do the same example as before. If I have that before I run the code, x is greater than or equal to 0, and I add 1 to x, it should be the case that afterwards x is still greater than or equal to 0. Well, if x is greater than or equal to 0, then x is greater than or equal to minus 10, certainly. This statement implies that statement. This is a stronger statement. This is a weaker statement. So I can replace the stronger statement with a weaker statement, thereby weakening my postcondition. So now what does the code say? Now what does the Hall triple guarantee? It says that if x was greater than or equal to 0 before, and I add 1 to it, then I guarantee to you afterwards that x is greater than or equal to minus 10. Well, I mean, it's certainly true, but it's less useful than it was. Again, we've weakened our postcondition by replacing it with something that's less useful to us. Now, be careful which one you're doing. Don't mix them up. Precondition weakening and postcondition strengthening do not exist. They're not rules. And the reason they're not rules is because if they were, you could prove really silly things. For example, take the Hall triple, x is equal to 4, and then I add 2 to x. Therefore, afterwards, x is equal to 6. This is a valid Hall triple. If I attempted to weaken my precondition, say I weaken it to, well, if x is equal to 4, that implies x is greater than or equal to 4. This is stronger, this is weaker. So if I attempt to weaken the precondition, I'm going to get something silly. I'm going to get that if x is greater than or equal to 4, and I add 2 to the result, then that means afterwards x is equal to 6. Which is clearly false. If you choose x equal to 1,000,000, or million's greater than 4, if I add 2 to 1,000,000, I'm not going to get 6. So this is silly. Similarly, postcondition strengthening is also bogus. And we can show that by the same thing. So suppose I have some code. X is greater than or equal to 0. I increase x by 1. And then afterwards, x is still greater than or equal to 0. Okay, this is a valid Hall triple. If I attempt to strengthen the postcondition, well, if x is equal to 6, that implies x is greater than or equal to 0. So if I try to strengthen the postcondition, what happens? I'm going to end up saying, if x was greater than 0 before I run the code, and I add 1 to x, then afterwards x is equal to 6. Which is again completely bogus, because choose x is equal to 3. 3 is certainly greater than or equal to 0. You add 1 to it and you get 4, therefore 4 equals 6, and that's nonsense. So don't mix these two up. It's precondition strengthening, postcondition weakening, not these cases.